Hello future engineers, welcome to my YouTube channel. To keep me refreshed, energized, and inspired, please don't forget to share my videos to your friends and to your friends' friends. That's the only way you can help me promote my channel so that I will be inspired to create more lecture videos and sample problem videos to keep me going and refresh so that I will not feel the tiredness in making this or creating these videos. So please help me. So this is my favorite method. For the beam shown below with constant EI by the conjugate beam method, determine the magnitude of P so that the tangent at B is horizontal, the deflection at C is 0. So let's select B as our moment center. That's the best choice. And before that, let's compute for the reaction at A. So summation moment B is 0, MB 0, so we have AY times 5.4 plus B times 1.8, then minus 1 half of 5.4 times 30 times 1/3 of 5.4 is 1.8. So solving for AY is equal to 27 minus P over 3, and let's transmit it as shown in the figure. AX is of course 0. So let's prepare the conjugate beam. The pin remains pin. This interior roller becomes interior hinge, and this free end C will become fixed as shown. So since we select this as our moment center, moment due to the triangular load is 1 half of 5.4 times 30 times 1.8, and it is a third-degree curve with value here equal to 145.8 over EI. 145.8 is 1 half of 5.4 moment of this triangular load about B. 1 half of 5.4 times 30 times 1/3 of 5.4, which is 1.8. So that's why we get 145.8. Then 27 minus P over 3 times 5.4 triangular loading is 145.8 minus 1.8 P over EI. And moment of P is 1.8 P negative over EI. Since the portion AB is the only simply supported and determinate portion of the beam, so let's consider this first. So for positive direction, we have theta B, and theta A upward. There's no moment or deflection because these are supports, so therefore no deflection. So we want theta B. In the first part, theta B is 0. So let's have for the area upward and this one downward. So moment A 0 equals clockwise positive. So theta B times 5.4 plus this area, which is 1/4 or 0.25 of 5.4 times 1 for 5.8 over EI. Because this is 5.4 over 5, 3 plus degree plus 2, 5.4 over 5 or 1/5 of 5.4. 1/5 of 5.4 is 0.2 of 5.4. Therefore, this distance is 0.8 of 5.4. That's why the moment arm is 0.8 of 5.4. Because this is 1/5 or 0.2 of 5.4. So its moment arm from A is 0.8 of 5.4. Then minus 1/2 or 0.5 of 5.4 times quantity 1 for 5.8 minus 1.8 P over EI. And this is 2/3 of 5.4, which is 3.6. So because this is 0, simplifying, theta B is 0. So the constant would be 850.3056. Then the constant here is 1417.176. Then plus 0.5 times 5.4 times 1.8 times 3.6 is 17.496 P. So take note that we just set EI equals 1 because that's constant. So we can now solve for P. P is equal to 32.4 kilonewtons. So in part B, the deflection at C is 0. So let's consider this portion. Let's solve for theta B. Theta B is no longer 0 in the second part. Only the deflection or delta C is 0 in the second part. So still MA equals 0. So we copy these equations here. So theta B 5.4 plus 0.25 5.4 145.8 over EI times quantity 0.8 times 5.4 and minus 0.5 of 5.4 times quantity 145.8 minus 1.8 P over EI times 3.6. So we divide everything by 5.4, so theta B. So we remove 5.4 here, we cancel 5.4. So 0 equals theta B plus 157.464, then minus 262.44 for the constant in this part, then 0.5 of 1.8 times 3.6 is 3.24 P. So theta B is equal to 104.976 minus 3.24 P. And considering BC, summation moment about C equals 0. So this is the equivalent area of this loading. So moment C equals 0 equals theta B 104.976 minus 3.24 P times 1.8, then minus area 0.5 of 1.8 times 1.8 P times 2/3 of 1.8 is 1.2. Then we just set EI equals 1, so there's no more EI here because it is constant. So simplifying, 0 equals 104.976. By the way, in this equation, we divide everything by 1.8. So we copy just this inside the brackets terms, then we remove 1.8 here. So 0.5 of 1.8 times 1.2 is times negative is negative 1.08 P. So only P is the unknown here. We can now solve for P. P is equal to 24.3 kilonewtons. So that's it for this problem.